So this is level 4 of expansions, and it's called the binomial expansion. And the binomial expansion is used in the following situations. Say, for example, you have x plus 2 to the power of 6. Or something like 3x minus 4 to the power of 7. Okay? These are going to be very, very long to expand out. So rather than expanding them out by multiplying each one by each one and then collecting all the like terms, we can use a little trick called the binomial theorem, okay, or the binomial expansion. So the binomial expansion, first you have to know what Pascal's triangle is. So here's Pascal's triangle, okay? We're going to go through it here quickly. So, the numbers in Pascal's triangle. We start with a 1 at the top, and then we do a 1 and a 1 below it, okay? Then, so the first line has 1 number, the second line is 2, the third line is going to be 3, so there's going to be a 2 in the middle because it's 1 plus 1 is 2, and 2 ones on the outside. The next line is going to have 4 in it. It's going to have a 3 here because it's 1 plus 2, a 3 here, 1 plus 2, 1 and 1 on the outside. The next line is going to have 5. 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4, 1 and 1 outside. Okay, and then you can see the next one is going to be 5, 10, 10, 5, and 1's on the outside. So there you go. That's Pascal's triangle. Now here's how we're going to use it. If I want to expand, say, x minus 3 to the power of 3, right? So here's the first line, here's the second line, here's the third line. Now I have to drop down one further, okay? So if I wanted to expand to the power of 3, I have to go to the fourth line. So this is the line I'm going to use. So remember, my number is 1, 3, 3, 1. So remember, I think, what was it we had? X minus 3 to the power of 3. So here's how you make it out, right? So we said our numbers were 1, 3, 3, 1 in that line of Pascal's triangle. So we do 1 times x times minus 3 plus 3 times x times minus 3 plus 3 times x times minus 3 plus 1 times x times minus 3. Okay, so 1, 3, 3, 1, and all I'm doing is multiplying it by x and by minus 3. Now I've got to fill in the powers. So the key thing here is that in each part, the powers must add up to 3, because 3 is what we're expanding to. So we can start off with x to the 3 minus 3 to the 0. And then we can make x1 smaller and this one bigger, 2 and 1. We can do this 1 and 2. And we can do this 0 and 3. So you see, you start off with the x being 3, and the minus 3's power is 0. And you make the x smaller and the minus 3's power bigger in each part. And they always add up to 3. And then what we do is we just put it together. So what have I got? I've got 1 x cubed, and minus 3 to the power of 0 is 1. So we're just left with x plus, now I look at this part, I've got 3 times x squared times minus 3, okay, which actually gives me a minus 9x squared. Okay, so this here gives me minus 9x squared. Now look at the next one. I've got plus 3 times x times minus 3 squared. Now remember, minus 3 squared is 9. Okay? So it's 3 times 9 is 27, so 27x. And then we go to the last part, which is here. And we just have x to the power of 0, so that means the x is gone, because x to the power of 0 is 1. And we have minus 3 to the power of minus 3, which is minus 27. And that's my answer. Okay? So I have expanded out x minus 3 to the power of 3 using the binomial theorem, or the binomial expansion. Right, let's have a look at something a little bit more difficult. So we have, so we're going to do 2x minus 2 to the power of 4. Okay, in that case we would go to the fifth line of Pascal's triangle, And in that case, in the fifth line of Pascal's triangle, my numbers you can check back are 1, 4, 6, 4, 1. All right? So what you can write down is 1 times 2x times minus 2 plus 4 times 2x times minus 2 plus 6 times 2x times minus 2 plus again 4 2x times minus 2 and then plus 1 times 2x times minus 2. Okay, now that's long. I'm sorry I can't fit it in the page neither. But now I'm going to put in the powers. So remember that this is to the power of 4 and this is to the power of 0. Then this is to the 3 and this is to the 1, 2 and 2, 1 and 3, 0 and 4. Okay? So now let's look at the first piece here. What does that simplify? 2. So it gives you 1. 2x to the power of 4 is 2x times 2x times 2x times 2x. So that's going to give you 16x to the power of 4 times minus 2. So that's going to give you minus 32x to the power of 4. The next piece is going to give you 2x cubed. It's going to give you 4 times 2x cubed, which is 4, times 8x cubed, which is 32x cubed times minus 2, so that's actually going to be minus 64x cubed. The next step, you're going to have 6 times 2x squared times minus 2 squared. So 2x squared, 2x all squared is 4x squared, times minus 2 is minus 8x squared. Or times, sorry, 2x all squared is 4x squared. Times minus 2 squared, which is times 4, 16x squared, so plus 96x squared. Then we have 4 times 2x is 8x, and 8x times minus 8, because minus 2 cubed is minus 8, is going to be minus 64x. And then we have minus 1 times 2x to the power of 0. 2x to the power of 0 is 1, minus 2 to the power of 4 is 16. Okay? So that's your binomial expansion. So I'm going to do some more examples of that in class for you to look at. This should just be a review. We're going to have some problems up that you can do in class as well.